Hey, welcome. So today we're going to dig into something you probably walk on every single day and just call dirt. But it turns out the ground beneath our feet has an origin story that is nothing short of epic. We're talking geology, biology, and forces on a planetary scale. Okay, let's get into it. And this quote right here, this really gets to the heart of it. You know, we tend to think of soil as just crushed up rock, but that's not the whole story. Without life, it's really just geology. It's the billions of years of biological activity that transformed these inert minerals into the living skin of our world. And it all starts with pioneers just like these. What you're looking at here is the very first step. It's a lichen, which is this cool partnership between a fungus and algae, and it's just hanging out on bare rock. The fungus releases these organic acids that literally begin to dissolve the mineral structure. It pries loose nutrients and creates the very, very first grains of what will one day become soil. It's pretty amazing. Life acting as a bioengineer. So you take that process and you repeat it over millions of years with countless organisms, and that's how you slowly build up that thin, precious layer we depend on for pretty much all of our food. So how does it really work? Well, believe it or not, scientists actually have a formula for it. Okay, this is called the state factor model. And I know it looks a little intimidating, but it's really just a recipe. All it's saying is that any given soil, or psi, is a function of 5 key ingredients that all work together over time. Let's break them down real quick. We've got climate, organisms, relief, which is basically the topography, parent material, and of course time. All 5 are absolutely critical, but today we're really going to focus on the foundation, the starting block for every single soil on Earth, the parent material. Parent material is pretty much exactly what it sounds like. It's the geological, or sometimes organic, stuff that comes before the soil. It's the raw ingredient that climate and organisms and the landscape are all going to act on over a long, long time. And it basically comes in 2 main flavors. I love this analogy. You can think of them as the stay-at-homes and the travelers. Residual material forms right there, in place, from the bedrock weathering just beneath it. But transported material, well, it started its life somewhere else entirely and got moved by one of nature's powerful delivery services. And this slide just illustrates that perfectly. I mean, look at the difference. Both of these are residual soils, formed in place. But on the left, in tropical Liberia, you've got intense heat and rain that have created this deep, red, super-weathered soil. Then on the right, in temperate Kansas, the weathering is way less intense, so the soil is much shallower and you can see it still kind of resembles its parent rock. Climate is a really powerful editor of that starting material. All right, so what about those travelers? How do they get around? Well, they use nature's 4 major transportation systems: gravity, water, ice, and wind. Let's start with the simplest one, gravity. This stuff is called colluvium, and really, it's just a jumbled pile of rock fragments that has tumbled down a steep slope. That means it's poorly sorted. You get these big, angular rocks all mixed in with finer stuff, creating the foundation for new soil at the bottom of hills and mountains. Next up, water. Rivers are like these giant conveyor belts for sediment. During floods, they drop all this material, called alluvium, all across their floodplains. You can actually see the distinct layers here, each one from a different flood. This process is what creates some of the most fertile agricultural lands on the entire planet, like the huge floodplains of the Mississippi River. And here you can see the unbelievable power of ice. During the last ice age, massive glaciers, some over a kilometer thick, acted like continental-scale bulldozers. I mean, they just scraped landscapes bare, gouged out mountains, and carved these classic U-shaped valleys, all while moving enormous amounts of rock and debris. And what they leave behind is this stuff: glacial till. It's a dense, messy, jumbled mix of everything the ice managed to pick up, from huge boulders to fine clay, all of it compacted under the immense weight of that glacier. This is the parent material for soils across massive parts of North America and Europe. And last but not least, we have wind, and its reach is truly global. I mean, just look at this. This NASA image shows a giant plume of dust blowing off the Sahara Desert. And get this? That dust travels thousands of kilometers across the Atlantic Ocean and actually fertilizes the Amazon rainforest. It provides essential minerals like phosphorus to one of the most vibrant ecosystems on Earth. So yeah, the Amazon is literally being fed by Africa. How cool is that? So, We've seen how rock and mineral fragments become parent material. But remember where we started this whole conversation? With life. It turns out sometimes the parent material isn't rock at all. Sometimes it's life itself. To see how this works, we have to look at really wet places, like bogs and marshes. See? There's not a lot of oxygen in that waterlogged ground, which slows down decomposition. A lot. So as generations of plants grow and then die, their remains don't really rot away. Instead, they just build up, layer after layer after layer, forming what we call peat. And this is what you get. It's a landscape built not on weathered rock, but on the compressed history of countless generations of plants. The ground right here is the parent material, a future soil made entirely by life. So after seeing rock get crushed up, tumbled down hills, carried by rivers, bulldozed by glaciers, and even blown across entire oceans, what's the big takeaway here? At the end of the day, knowing a soil's parent material is like reading the first chapter of its biography. It tells you exactly where it came from, what it's made of, and that sets the stage for the kind of life it can support. It's literally a record of our planet's history, written in stone and silt and clay. So the next time you go for a walk, I want you to take a closer look at the ground. Is it sandy? Is it clay? Is it full of rounded river stones or sharp, broken rocks? Every one of those is a clue that hints at a dramatic past. So I'll leave you with this question. What story is the ground beneath your feet trying to tell you?